The climate on the Washington coast is very interesting. As global temperatures rise, the oceans warm and expand, and the ice caps and the glaciers melt. This causes the sea levels to rise. And speaking of rising, the global sea level has risen 7 inches during the 20th century and is supposed to rise more every year. The Washington coast is actually projected to rise 24 inches in the future. The sea level rise in this region is projected to be lower than the global average because the tectonic plate movement is causing the land to rise about 3/5 to 11/5 inches per decade. Most damages to the Washington coast is caused by storms and their large waves, storm surges, and bad tides during El Niño. This increases the risk of coastal flooding and coastal erosion. For the Washington coast pollution, 1/3 of Washington's water is too polluted to meet the state water quality standards. More than 60% of the water pollution comes from cars leaking oil, fertilizers, and pesticides from farmers and gardens, failing septic tanks, pet waste, and fuel spills from recreational boaters. There's also other types of pollution, like non-point pollution. Most of this pollution in Washington state's waters come from many different, hard-to-trace sources with no obvious point discharge. This is what non-point pollution stands for. Also, there's point source pollution. Ecology protects water quality by limiting how much pollution industries can discharge into our waters. Pollution from industrial pipes is called point source pollution, hence the name. There's also stormwaters. Stormwaters are rain and snow melts that run off surface such as rooftops, paved streets, highways, and parking lots. As water runs off these surfaces, it can pick up pollution such as oil, fertilizers, pesticides, soil, trash, and animal waste. When stormwater goes into a storm drain, it is not treated. It goes directly into the Washington waters. The weather on the Washington coast is pretty bad, actually. During the winter, Washington gets awful storms, combining for 70 to 100 inches of rain a year, which is the most precipitation on continent north of Guatemala. The coastal storm winds get up to 40 miles an hour, and the most ever was 55 miles an hour. These storms cause the wind to push water up to the shore, and low pressure raises sea level. In the summer, fog often moves in along the Washington coast. As the Pacific High, an area of the high pressure, it cools off over the Pacific Ocean, low stratus clouds form, and at night these clouds move inland as fog. The Washington coast also has something called the Aleutian Low, which, quote, large cyclonic systems sweep down from the Alaska Panhandle, bringing storms to the Washington coast. Cyclonic systems sometimes line up, one after the other, causing stormy weather on Washington's coast for weeks. Storms spawned off the coast of Japan and Siberia, circle around the Pacific High into the Aleutian Low, rekindling old storms and starting new ones. Not only do they have the Aleutian Low, but they have the Cape Disappointment, which is at the mouth of the Columbia River, and it's one of the foggiest places in the world, with an average of 106 days of fog per year.
The green crab, or Carianus minius, is a non-native predator that feeds on shellfish. It is native to Europe. The green crab is considered an aquatic nuisance species in the United States. Studies suggest that the green crab larvae arrived in Oregon, Washington, and British Columbia by strong currents produced by a large El Niño event of 1997 and 1998. The concerns that the range of this crab could expand quickly, affecting both shellfish and Dungeness crab populations. The humpback whale can be seen off the Washington coast, where it feeds in the summer. They travel to the Mexico-Hawaii area to breed. They primarily live in offshore waters, continental shelves, and seawards. Whales can mistake plastics and other trash for food. If they eat these, they will eventually die of starvation. The snowy plovers are rare, endangered shorebirds protected by law. These small shorebirds do not build nests. They lay eggs on the scrapes in the sand. If snowy plover adults are frightened from their nests, the eggs can be baked by the sun, chilled by rain, buried by sand, or eaten by predators. These newly hatched snow plovers chicks are hard to see. They are easy for beach walkers, joggers, cars and dogs and horses to accidentally crush. Litter left by people attracts predators such as crows. As beach grass spreads, the snowy plover loses habitat. Snowy plovers nest in open, flat, sandy beaches above the high tide line. Once planted to stabilize dunes, beach grass has reduced the amount of bare sand above the high tide line, decreased with the width of the beach, and increasing the slope of the beach. The Oregon silver spot butterfly was found along the Washington southern coast. The butterfly made its homes in coastal salt spray meadows and fringing forests. The grasslands that the silver spot requires are naturally controlled by fire, wind, and salt spray. With homes moving into the grasslands, fires are controlled. Trees and shrubs then invade the meadows and eliminate silver spot habitats. The western blue violet is a key food source for silver spot larvae. It is rare due to its habitat loss. Cars increase the butterflies' mortality because the roads cut through their meadows and butterflies usually hit the car windshields. And non-native plants such as Scots broom crowd out the butterflies' native food sources. The coho salmon is a very popular sport fish in the Puget Sound, coastal stream, and tributaries, and sometimes in neighborhood stream. The coho spawned in the coastal streams and the tributaries of large rivers. The waters need to be of medium ferocity and have small to medium-sized gravel, because they use the gravel to put their eggs in. In the Idaho, Washington, and Oregon areas, they keep track of all the adult salmon counts for each year. In the Willamette Falls area, about 2,944 coho adult salmon were caught, and about 2,587 jacks. We also need to be concerned by this because this also can disrupt the salmon's natural path for reproduction and going out to the sea.
River dams also affect the natural flow of sediment down the Columbia River to the delta. The Washington coast is made up of a total of 219 dams, all of which contribute to the health of the beaches that make up its precious coastline. According to a Washington erosion study conducted by the Washington State Department of Ecology, the Columbia River was responsible for carrying about 12 million cubic yards of sediment to the coast each year prior to river dams. Now that sediment flow has decreased, the delta has begun to shrink, contributing to less buildup on Washington's beaches. As mentioned before, El Niño is a recurring ocean atmosphere phenomenon. Abnormal warming occurring during the winter months along Washington's coast is the result of El Niño. El Niños can bring extreme waves from the south and southwest, more frequent severe storms, increased sea levels, above average river flows, warmer than normal water temperatures, and flooding, which all contribute to the erosion of Washington's coastline. The Columbia River Jetty was designed to help form sand at the delta and also help work to build up beaches in the surrounding area. Although it has resulted in buildup of beach on the south side of the jetty, it has caused erosion of beach on the north side of the jetty, due to the direction of the longshore current. Coastal erosion has been an increasing issue for Washington's coastline. Erosion is defined in our textbook as the group of natural processes including weathering, dissolution, abrasion, corrosion, and transportation, by which a material is worn away from Earth's surface. River dams, El Niño, jetties, and groins all contribute to the erosion of beaches and land on Washington's coast.